You are looking at spreadsheet NC-180, Riffle Pool Final Design. And we'll talk about how the spreadsheet is constructed. You are going to get a copy of this spreadsheet, so you just need to learn how to use it. Developing the spreadsheet would take a little bit too much for you at this level. So you'll notice the first thing over in columns B, C, and D, I have copied the results from the Lingo file, which analyzes and optimizes the size of the pool cross-section. So you can see the end values of the pool and the riffle, the geometric information for the riffle cross-section, and then the parameters which were used in the Lingo file to optimize the conveyance, which came out to be 9294. Of interest to us are the values of the side slopes in the pool and the widths of each subsection. From the side slopes and the widths of each subsection, we can develop the pool cross-section coordinates. So up here, you'll notice that the widths of each subsection and the side slopes of each subsection have been copied. As I continue to move to the right, here's the information about the riffle cross-section. From this information, I can put together a riffle cross-section, a typical riffle cross-section, which will then be inserted into HEC-RAS. The normal coloration of the cells applies. So the yellow cells are the user input. The green cells are copied, and the blue cells are calculated. So you can see here, I chose 100 as the top of bank elevation, went up a little bit out to the end of the floodplain, and then up 3 feet on a 1-to-1 slope at the end of the floodplain. So now I take this information and I combine that with the relative percentages of the riffle, glide, the pool, and the run. The overall length of the riffle pool sequence is 140 feet. So these would be the lengths of the individual facets. Now, what I have to do is make sure that the bottom slope equation balances. So if we take the overall bottom slope of 0.006 and we multiply by 140, we get 0.84. I then adjust these slope factors, like you did for the rectangular sections, to make sure that this 0.084 and this one are exactly the same number. So you see, looking at realistic ranges of the bottom slope of the riffle, glide, the pool, and the run, I come up with this combination, and this gives me the bottom slope of each facet. This is just copied here. As you can see, the riffle on this line is the same as the riffle on this line. Now, once I've got this bottom slope information and the lengths, I come down here and I build my cross sections for HEC-RAS. So you notice I named the sections from 10 up to 100. Above each section, I put the length to the downstream next section. So that I will put into the program. And then you notice I copied the first riffle section in. This would actually be at the downstream end of the riffle. Now at the upstream end of the riffle, I put in another riffle section. And then I start working my way across. So you see that here's a glide section. The glide and the pool cross-section will be the same. So these are the numbers from the calculations using the pool information. So these are your stations, and then these are your elevations. I guess HEC-RAS calls these the offsets. So then I continue to work my way across that way. So you see I have 2 riffle cross sections in a row, then 2 pool cross sections in a row, 2 more riffle cross sections, 2 more pool cross sections, and finally 2 more riffle cross sections. I then have all of the stations and elevations for each of the cross sections. So now I go into HEC-RAS and I make a cross section 10. I copy it over 9 times, and here I have put in the bottom adjustment elevation. So I will copy the cross section and then I will paste the information from the geometry in, and then adjust the bottom elevations by the amount that is shown here. Now, to check to ensure that my profile is reasonable, I copied the numbers from the Thalwag, and you can see this would be what the Thalwag bottom profile would look like, and this is the top of bank profile. So this information, once it's entered in HEC-RAS, we can run the simulation of the integrated design of the Riffle pool sequence.